Hey guys, so here are the answers to the problem that you guys had been working on. Because I know that's, they were, well, the first one, you had to know how to draw the picture. So hopefully seeing this, hopefully you got the right answer. But if not, hopefully seeing this will be helpful. So Elliot's playing football, 6 feet tall. So I'm going to draw a picture of Elliot. Okay. This is Elliot right here. And he stands halfway between two floodlights. So floodlights are those things that that shine the light on a football field. And he's exactly halfway. So the floodlights are 12 yards high, so I'm going to make sure that this is 12 yards high. Now, he is actually 6 feet tall, so that's going to be important to know. So there are 3 feet in a yard, so that means he is going to be 6 times 3. I'm sorry, there are 3 yards in a foot. So he's actually going to be 2 yards. So 6 divided by 3. So next. All right, so next, this is also 12. And they're 50 yards apart, which means from here to here is going to be 25. And from here to here is going to be 25. The whole goal is to create triangles. So the floodlights give Elliot 2 shadows. So that means the path of the floodlight hits Elliot and then creates a shadow behind him. And this one does the same thing. Now, I don't know, the question is to find the length of the shadow. So that would be this right here, from here to here, which would be x. Now, what's really important to know is that there are some similar triangles in here. Because, for example, let me go ahead and draw the triangles. Oops, sorry. Here's a big triangle at a right angle that goes all the way to here. This is a smaller triangle that has a right angle that also has this angle right here as well. So this smaller triangle and the big triangle are actually similar. So we're going to use that information to figure out x, which is the length of the shadow. So now we know parts of the triangle. Remember, similar triangles, you could set up corresponding parts in a proportion. So the length from here to here is x versus the base of the triangle, which we just found out is 2 yards, would equal this length. Now, what is this length? Well, from here to here is x, from here to here is 25. So the whole length would be x plus 25. And then the floodlight, the base, which is 12. So if I solve this proportion, I'm going to get the shadow. So 12 times x, 12x, 2x plus 50. Subtract 2x on both sides, 10x equals 50, which means x equals 5, which means the length of Elliot's shadow has to be 5 yards. All right, this problem I thought was a little tougher, but a little information it gives you. First of all, this is a 1x1. The white cue ball is 1 foot away and 1 foot higher than the corner. And then I want to try to make 2 different triangles. So we want to know, when will this actually go into the pocket at the midpoint? So let's make 2 different triangles. And the reason why I know that if I create 2 different right triangles, they're going to be similar is because you have 2 right triangles, and we talked about in class that this angle and this angle have to be the same. Where it goes in, where it comes out is going to be the same angle. So these 2 triangles are similar. So let's see if we have enough information. This from here to here has to be 7 because the whole thing is 8 and it's 1 less. I might not know where this is, but I do know that this whole thing is 4 and it's 1. So this whole thing is 3. So if I call this x, then this would be 3 minus x. Because I do know that this is halfway, which is 4. So I have all the information except for these lengths, which is going to tell us exactly how far to put that ball, or to aim that ball. So let's do a little proportion. 7 is to 4, the length of 4, as x is to 3 minus x. And if I solve this proportion, I get 7x equals 12 minus 4x. I'm going to add 4 on both sides. So you get 11x equals 12, which means x equals 12 over 11. So that means that if you put 1 and 1/12 feet down from the north wall, basically 12/11 down this way, that's where you should aim the cue ball. This one. Oh, sorry, that was the other problem. Oh, sorry. Now, in this one, you want to hit the ball right here. So we want to find out how far. It says, by placing the 8 ball from the east wall, show the driver, if he shoots the ball exactly as he did before, the cue ball will strike the ball directly and sink the 8 ball into the north pocket. So basically, we know where he wants to hit it, so we know that this is 12/11. We also know from here to here is 2, and from here to here is also 2, because it says it's directly in between, 2 feet from the east wall. The whole thing's 4. So what we want to know in this problem is, I believe, how far to place this. What is this length right here? So again, we see 2 triangles. We see a small triangle and we see a big triangle. So this x, we'll call this x right here, is to 12/11 as 2 feet is to the whole side, which is 4. And if you solve this proportion, you will get your answer. So 12/11 times 2 is 24/11, which equals 4x. So I'm going to divide both sides by 4, which essentially means I'm multiplying 24/11 times 1/4, which gets me my final answer of 24 over 44. That reduces to 12/22, which reduces to 6/11. So if you move the cue ball 6/11 feet from the north wall right here, 6/11 of a foot, that's where you should place the 8 ball.